share my screen.
Yeah. So this month, Anton kindly offered to present a talk about HTTP services in Rust, and I think it's kind of a follow-up from the last month's WASM talk, but not entirely following up. So, floor is yours.
Cheers, thanks. Yeah. So it is a little bit actually. So the WASM piece, there was about microservices, etc. But this is very much focused on building HTTP services in containers. And I'll sort of dive into a little bit of what containers are, etc., etc. Just to introduce myself, I'm Anton Whalley. I'm what they call a cloud technical professional in IBM. So I help our customers deploy IBM software into cloud environments, predominantly container-based, but very much sort of hands-on, helping people get up to speed with that across the UK and Ireland. So thanks everybody for attending, and thanks for recording this. It's obviously what I'm going to talk about today. It's very much my own point of view. I don't sort of represent IBM. This isn't IBM's official point of view. It's not either. I'm going to talk about some projects that I contribute to as well. It's not necessarily the opinions of the projects that I contribute to. It's very much my own point of view. Okay, so with that said, and the final piece, of course, yeah, you can get me as at Digit9 on Twitter. I do Twitter quite a lot, so I appreciate anybody that reached out to me there and pings me. Okay, so we're going to just get focus on this. Resume slideshow. Is that working now? Yeah. Okay. So the running order for this. I'm going to look specifically then at Rust, the benefits of using Rust for HTTP services. I'm then going to share some of the selection criteria I've seen on the web that's been shared by some other folks in the Rust community, and then give my own spin of sort of how I think and select open source frameworks and HTTP frameworks in particular. And then I'm going to show some software development processes that are container focused, very much looking at Knative and serverless stacks, but we'll get sort of more into that as we go through the talk. Okay, so just to make sure everybody's on the same page, I am going to mention containers a lot. What I've noticed when I've given presentations like this, particularly to customers, etc., some folks have a different notion of what sort of containers are. So I just wanted to sort of clarify what I mean when I'm talking about containers. It's the only sort of definition I'm going to have before I start the talk, but it's sort of handy to have. Okay, so containers are basically a way of isolating differences between applications. You package that into a container, and that allows you to deploy it into multiple scenarios. Okay, it's a type of virtualization, and it's very much seen as the Goldilocks of virtualization. So and I'll compare it between hardware level virtualization on the next slide, just to give you a sort of picture of what that is. But it's very much, it's got a lot of flexibility. It's got flexibility that's comparable to virtual hardware level virtualization, and it's not as prescriptive as certain sort of PaaS technologies that have come prior to it. Okay, so specifically then, sort of on the left-hand side, you have basically virtual machines or hardware level virtualization, and this is what people would have been used to up on Amazon, spinning up EC2 instances, etc., etc. You'd have a server at the bottom, a bare metal piece of server with a host operating system. That host operating system would have a hypervisor, which is in a hardware abstraction layer that would then allow you to install guest operating systems. And then within those guest operating systems, you'd put libraries, and then you, on top of those libraries and binaries, you put applications. Okay, so this was when it was 10 years ago, when people were talking about cloud deployments. This is predominantly how people were doing it. And what we're seeing is the shift away from that type of deployment technology into containers. So as you can see, there's a lot less colors in the boxes on the right-hand side. It's a server, it's a host operating system. You can share libraries across different applications. and there's a lot less abstraction between what you're running and the instance that it's running on. Okay, so the benefits, I mean, you can see there's just a lot less software involved in the right-hand side, and a lot of maintenance overhead, a lot less of wasted compute. And that's what I mean when I speak about containers. I'm talking about operating system level virtualization on the right-hand side there, okay? So with that, let's jump into Rust. And Rust's largest use case, and this is from the Rust Survey 2019, published 2020-04, so April this year. This was the survey that was across Rust users. What are the types of things that you work on when you're using Rust full time, okay? And as you can see there, by a fairly substantial margin, it's back-end web applications. So a couple of, not the WASM one, but the talk a couple of months ago, we were talking about sort of where in organizations that we work in, where are the sweet spots for us to go and talk about with our colleagues, where we should think about deploying Rust and using Rust within those organizations. Definitely go and talk to the folks building out the web services team, the web service applications. There seems to be a lot of traction in there, and as you can see underneath that, they've got distributed systems, network programming. So there's definitely a clump of use cases that people are having success with in the community that point towards building out services with Rust. Okay. I've put a link, but I'll share the slides as well. I'll put a link to that survey so you can take in sort of the full depth of it as well. Okay, so that's really the premise of why I want to talk about HTTP services. It's actually a really good sweet spot for what for socializing Rust and bringing Rust into your organization. And then as well, sort of the background to that, and I did warn you, I was going to say a lot about containers a lot. We are also seeing a growth in containers in production, okay? So we're starting to see sort of the growth, since last year, we're starting to see a 10% growth of folks that were using containers in production. 73% of the CNCF folks that were surveyed, we're now starting to see 84%. And on the very right-hand side of this, we're starting to see sort of clusters, 55,000 plus clusters. We're starting to see that sort of depth of deployment grow. And from a personal point of view, in terms of what the amount of people that I'm talking to, and the amount of activity that we're seeing sort of roundabout, certainly in IBM, with containers and as part of the software development lifecycle aren't going away. And everybody's sort of starting to understand that the benefits of using them are starting to come to the fore, okay? So what I have noticed, and this is, so I also work in IBM as, I also work with Red Hat. I'm a Red Hat ambassador in Ireland. What that means is that I work with the Red Hat technical teams, and we put together sort of work on architecture and best practices for containers and container deployments. And this is something that we're sharing. We started to share sort of externally, so I'm sharing it with you now. But we've noticed that traditional application technologies don't play particularly well in container environments. We're not getting the deployment density that we'd like to see using all the technologies. All right, so if you look on the left-hand side there, we're seeing JVM deployments where you'd only say get 4 JVM applications deployed onto a single piece of compute. With Node.js, you're getting a lot better density, but you're still not getting as much density as you would get with Rust, okay? And this is something that you're going to see sharing more and more within the container community. We're starting to see a move towards, towards Go, towards Rust, and towards native compiled Java technology as well, which is kind of exciting for us because it means people are starting to understand the benefits of running native compiled applications. So I did some specific measurements on this. I did a blog post. This is in my blog on venture.com. And if these are sort of cold services, so I built a Spring Boot application, deployed it, built a Node.js Express application, deployed it, built a Rust Tide application. Rust is something I'm going to talk about more in detail in a bit, but basically a Rust HTTP service. And you can see the memory footprint and the CPU footprint difference between Java, Node, and Rust. So it's literally an order of magnitude difference in between your cold application runtime. And these, when you're talking about deploying a lot of microservices into a production environment, these numbers actually mean a lot, because the more compute you have to deploy in order to support your footprint, the more it's going to cost you, the more it's going to cost the planet eventually, I guess, and operationally, the more overhead there is with it as well. So these, when you start to talk about order of magnitude differences, that's a number that's going to be interesting to your operations folks, to your leadership, and you should think about talking to them about it. Okay. And okay, so we've seen that we've seen this problem of density of deployment in sort of from a container world. And from a Rust point of view, we're saying it's a good opportunity to run to Rust, but we're also seeing that the Java teams, the Java folks and the Node.js folks are starting to look at technology where they can try and match the footprint that you can get with Rust. So this to me sort of validates the point of view that we have, that people are, that deployment density is an important topic to be discussed and to be managed. So from Java, you'll see things like GraalVM, which allows you to deploy things like Quarkus, Vertex, and JavaScript applications within that. And it's basically a compile to native technology. And in Node.js, we're starting to see things like Persina and isolated VM, where basically you have a single Node.js process that has lots of embedded isolates in there that act as sort of single mining, sort of smaller processes within the process. But again, it's all about sort of trying to get this application density, which Rust sort of gives you for free. Okay, so that's sort of deployment density and sort of the benefits of running sort of Rust and native. So while because these application runtimes, be they Java, Node, are starting to look at different technologies to meet the footprint of native, it means that there's an opportunity to look at it means there's going to be a churn of software development lifecycle anyway. So and what I'm trying to get across here is if your teams are starting to look at things like GraalVM or looking at different ways to develop their Node.js applications, you should definitely take the opportunity to go, okay, if you're going to have to implement new software development lifecycles for this, you're going to have to bring in new tools, you're going to have to change your operational constraints. That's an opportunity to go and have a conversation about using Rust and look at the trade-offs between using Rust and bringing in all this. So jump back here. So bringing in all this new virtual machine technology or native compilation technology, etc., etc. It's like, do you want that overhead when you could just build it in Rust and be straight on the metal with it? Okay. And again, the security implications with bringing in VMs and new technology layers within your stack, whereas Rust could be a lot easier to audit from that perspective. And then finally, Java, Node, Go, they're all still GC'd, whereas Rust isn't GC'd. So I haven't mentioned this previously, but I'll jump into the slides now. So even with those newer approaches from Java, from Node, from Go, you're still going to have this type of problem. So this is a super interesting blog by the folks at Discord. Discord are moving quite heavily into Rust. And what we're looking at here is latency spikes and CPU spikes from their Go services. Okay, so there's some particular backend services that they built out using Go. It got them so far, but the latency spikes for certain types of functions and features that they had in the business, they just couldn't handle these. The numbers are in that little blog post at the bottom. It's well worth a read. But even with something that's sort of compiled to native, which is Go, if you still GC'd, you're still going to have problems on backend services, which is, again, the sweet spot for where Rust is. And again, taken from the blog article, but you can see what you're looking at here is the purple, which is the Go stats from the previous slide, with the Rust stats mapped over in blue there. So you can see there's just no spikes. You don't get it. There's no GC. Surprise, surprise. There's no spikes. And critically, you don't get these high 95th percentile spikes where you're getting response times of over 300 milliseconds. They can be really, really disruptive to service. It's hard to tune for that type of thing when you get these spikes. You just don't get that type of thing with Rust. And this, certainly from an operations and a and there's more focus on user user experience, etc., etc. These types of numbers where you can say it's not going to take a web browser, a web application, an extra whatever half a second to load. These are quite important numbers, and there's some stats from Google in terms of application drop-off times or user drop-off times when you don't get your application response out fast enough. These are impacting, and they impact the bottom line. Okay, so that's the benefits of Rust for HTTP services. I'm now just going to talk a little bit around selecting a HTTP framework. Okay, so there are 4 that I'm going to look at, and they are Rocket, Actix, Warp, and Tide. Okay, they're all pretty well known in the community. Tide, not so much perhaps, but the other 3 would be quite well known. And for a lot of this section, actually, I'm going to borrow from this blog post down the bottom, which is Luca Palmieri's. And apologies, I probably slaughtered his surname there, but it's a great blog post where he dives into how he evaluated these web frameworks. He looked at sort of the adoption as a criteria, and as you can see, sort of Actix is very, very popular. It's also got very, very high performance. It's on top of all the metrics charts in terms of HTTP web server performance. Rocket would be pretty well established as well, and the newer ones, Warp would be well regarded, and Tide's just started to kick off in terms of a web service framework. Okay. In terms of async support, this was important, I think, when he wrote the article, but they all have async support in there. In terms of HTTP service framework, HTTP service development, async is massively important. The complexity of your code base when you don't have async, I think, is for building business level APIs and business level services. It really, it's too much, I think, if you don't have an async framework that sort of abstracts all that kind of things away from you. I know you've been able to do it in Rust for a while, but definitely the news at the end of 2019 that we had sort of async fully supported was massive. I think that's why, again, we can start thinking about building these network type services. So yeah, all of them support a form of async, and Tide specifically on async standard. And then in terms of the ecosystem around them, so these are sort of crates that add additional functionality on top of the web service framework. Rocket has 178 add-ons, Actix 113, Warp 57, and again Tide coming in quite low there with around 20. And this is sort of to understand sort of how healthy is the ecosystem from potentially from a wider adoption approach. Okay. So they're the types of criteria that Luca looked at in order to select a web framework, but I chose a slightly different criteria. Okay, so I've been involved in open source projects for around 10 years. I've been involved in Node for a while, Node.js for a long time, and it's allowed me to sort of understand the different dynamics that are within an ecosystem, what I like about an ecosystem, what I don't like about an ecosystem. And one of the things I did when I was looking at these frameworks was look at the contribution ratio that you get within a for each of the HTTP service types, the framework types. And as you can see, Actix, Rocket, and Warp have a very, very similar profile in terms of their contribution pattern. There's a single developer that drives it along, and people, to the best of their ability, provide patches. Okay, so and I'm certainly not here to sort of denigrate anybody who's working on open source, but as a personal choice, it's not something that I look for in a project. These types of things can be problematic and we've seen it ourselves actually recently with Actix. And again, I don't want to sort of call out, the Actix developer got into quite a stressful situation, and he's recently had to hand over the project because fundamentally, to me, looking at the posts on GitHub, that looked like burnout to me. And I've seen it so many times in sort of one-person projects or hero projects, as they tend to be known, where it just gets all too much for people. And when you contrast that to Tide, where you can see even from the language they use on the landing page, but even whatever you put on a landing page, the sort of web browsers never refuse HTML, but as the saying goes. But when you look at the actual commit logs for Tide, you can see a way better spread, a much more healthy spread across the project, as opposed to the others. And that to me was sort of a key factor as why I chose and sort of went with Tide. So yeah, I mean, just moving on from there, whatever you're choosing any open source project, I think now that open source is a lot more predominant. We're almost spoiled for choice. So we can, most of the time when we look for an open source solution, there's more than one out there that we can go and choose and pick from, okay? So I would strongly recommend that you understand the values of the community that you're going to potentially be working with, and make sure that those values align with your values. If not, it's going to end up in tears at some stage. And like, even if we look at, again, I don't want to reference it as a bad case, but if we look at what happened with the Actix GitHub Q&A, somebody pushed or tried to put in a pull request to make some of the Actix code safe. Rust is all about safe code, and from a wider Rust community point of view, there's nothing wrong with this PR. But from an Actix point of view, where they're predominantly focused on performance, and however they get there, they don't really mind, there's a conflict of values. And whoever's putting the pull request in didn't actually understand those values very well and wanted to push. And there was other people in the community that pushed that along as well and wanted that change to land. But the point is that everybody should be aware of why the pull request might get pushed back. Does this actually match with the values that the framework or the open source project that you're delivering to has? So that's the main takeaway. So choose any of those projects, choose any HTTP server framework, just make sure it's what you want out of it. As I say, I chose Tide because it labels itself, brands itself as a fast and friendly HTTP server framework. That's what I want for an open source project. I don't get paid to go and work on it. So I just want it to be a nice place to go and work. As I mentioned already, the collaboration focus, there's a discussion forum on Discord. You can go and log in and have a conversation with the folks. You can share sort of code snippets that you've done, et cetera, et cetera. And what I also liked about it was the architecture. It's what's called the Node.js middleware approach, which I'm very, very familiar with. So it feels like putting on some comfy trainers, which is sort of the sealing the deal for me. But I would have adopted a newer architecture if I'd have still got the top three. Okay. I can't see any questions, by the way. So apologies if people are typing things and I'm ignoring you. But I will, if there is anything, we'll get to the end, I guess. Okay. So that's how I went about sort of selecting a HTTP framework. So that's all fantastic. How does that align with my software development process? Okay, so I am, as I mentioned, predominantly focused on containers. Okay, and in containers, predominantly focused on Kubernetes and that environment. But there's problems with Kubernetes. Okay, and when you go and work with plain Kubernetes with software development teams, it doesn't offer the acceleration that you would expect to get from something that sort of has the operating system level virtualization that I mentioned, sort of all these high performance aspects that beat sort of all the technology. In some of the adoption that I'm seeing with Kubernetes, we're not seeing that sort of acceleration move up the stack and into the business. And it's probably predominantly because, and there's a talk I've referenced at the bottom here by Kelsey Hightower from KubeCon 2018. And it's predominantly because Kubernetes in and of itself is a container platform, is a platform for building container platforms. It isn't really out of the box, ready for use. It's very much batteries not included, assemble your own logging, assemble your own CI/CD, bring your own storage, work out the networking, like all the things that you see on the bottom of this on the bottom of this chart are all problems that people who just start with Kubernetes, the sort of the feedback that they get from a developer point of view. And that's not surprising. It's certain people have marketed Kubernetes as sort of the solution for all developer problems, and really it's just the platform that you need to build on to go and solve developer problems. And this came back, so there were developer specific problems, but this is from the CNCF survey, and it's out on the new stack as well, but this is, as well as the developer sort of pushback that we're seeing, there's also this feedback or this point of view from the operators and from an operator point of view. So Kubernetes needs to be better operator experience. It needs to have better multi-tenancy. It needs better observability. It needs better serverless support. Okay. So what we've done, what Google have done, and what IBM have been working with Google on alongside Red Hat is sort of building this Knative technology that basically sits on top of Kubernetes and makes Kubernetes usable, a lot more usable for developers than sort of plain old Kubernetes as well. Okay, so what we're going to look at is using the tied HTTP framework in this Knative environment. So as I mentioned, it's Knative is what they brand as a serverless stack that sits that extends Kubernetes. It's fundamentally a set of middleware components, and it's designed to allow you to use containers across clouds, across data centers, etc., etc. All right, and for the more, what am I trying to say here? So there are traditional, what we call traditional serverless platforms, or public cloud provider serverless platforms. So Lambda on AWS, you may have heard of. Functions on Azure, IBM functions on IBM Cloud. I'm sure there's others that have them as well. But Knative differs from sort of these more public cloud available platforms because Knative allows you to have user-defined resource management, which means that if you're using AWS Lambda, you can only compute for a certain amount of time before it times out. You can only use a certain amount of resources. Otherwise, you've got to rewrite your code and go and put it somewhere else. Whereas with Knative, you can define the buttons or levers that you can twist in order to give yourself more compute if you need it. But it starts with sort of sensible defaults. And because it's container based, you don't have to rely on AWS supporting your language or supporting this particular version of your runtime. You don't have to rely on IBM to provide you a particular runtime. You can just build a container with whatever technology that you want to run and deploy it within this serverless paradigm. And that's why I really like sort of Knative. There's a good sort of balance there between the benefits of using this serverless idea where you just build code on your machine and push it somewhere and let somewhere deal with it, and being able to manage that as the particulars of your application change. So spend too much time on this because I can't just ruin a Rust meetup, not necessarily a serverless meetup, but I just want to give sort of folks a bit of context. So what is this Knative? What are the components in a Knative deployment? You basically have a route which routes traffic to particular deployments which are defined within a service. Okay, that's what Knative is. It's a container that's deployed, automatically routes, and does revision management for you. Okay, so that's how the service side works. And then it also has an event system, so you can connect your Knative environment with Kafka or some event producing middleware, and you can, when events happen in your Kafka topic, you can broker those into an executable environment in your Knative instance as well. So there's sort of both sides of the microservice, typical microservice architectures. Your events and your APIs are covered within Knative. And now, what I've done over the past 6 months really is I've been bundling up tied into a open source technology called Appsody, which is a set of developer tools that allow you to predefine services and developer projects, if you want to call it that, in order to accelerate development of Tide APIs. All right. So this basically, this is the use case is that you're an architect within an organization, and you want to specify that, yes, I want to allow my developers, or want the developers to use things like Rust, or and I want them to use Tide, or I want them to use Rocket, but I want them to use it in a specific way that I'm comfortable with and the business is comfortable with. So you can specify these templates, and once you've specified those templates, you can give them to your developer teams, and they can use them to build container components or Knative components, and deploy them within the software development lifecycle. So Appsody has support for Spring, for Liberty, for Node, for Swift, and as I mentioned, it has got support for Rocket, and it's got support for plain Rust applications, and it has some support for Tide as well. Okay, and we'll have a look at sort of the detail of what one of these packages looks like. So I'll just take you through the Rust package, the Rust Tide package, but we'll also have a look at sort of this workflow down here. So what does Jane do as an enterprise software developer? As a software developer, how does she use Appsody to sort of build an app, run it, and deploy it? Okay. As I mentioned, there's two sides to it, to a Rust Tide service. There's the application block, or the backend service, and that's defined within a Rust Tide project, or Rust Tide stack, if you want to call it that. And really, it's just a main function with a wrapper around a plain Tide service. So it does things like set up a port and sets up a service to listen on the port, and then it borrows in, or sorry, it uses in this application, which is actually defined as an external dependency, and it's and we'll have a look at sort of this external dependency. But it's, you do your application development, or Jane would do her application development within this package, and then at runtime or at debug time, the two would be pulled together and deployed. And that's how you get this sort of this management, or you put in these sort of constraints around what the application's what the overall application's capable of doing, and where the business logic resides as well. Okay. So when I start a project within Appsody, I can just list this off now. I'll go here, I think. So if I go Appsody list, these are, I'll just minus that there in a bit as well. There we go. Okay, so you can see the different projects that I have available to me within the Appsody environment. As you can see, some of the things I mentioned there, Quarkus and Java, Spring Boot, etc., etc. We also have Rocket, Rust, and Rust Tide. Okay, and then when I want to create a project, just create a directory. Sample. So. And so what this is doing is just initializing an Appsody Tide project. Okay, so if we just have a look at what that generates for me, it creates this standard sort of cargo library. Okay, and this cargo library is just a function. Okay, so it basically returns a Tide server definition, and I have this API object that I can just extend as I would a normal sort of serverless or function as a service type idea. So when I'm developing, I don't have to think about what my server's doing, how do I package my server, what libraries do I need for my server, etc., etc. It's very much just about build, deploy the code. Just think about the code that you're deploying. It's very, very function focused. But you can extend this to be sort of a series of API requests. As you can see, currently this is API at / and I'm just returning sort of hello world. That's the default sort of implementation that you get. But you can grow that out, obviously, to be as big as you want. But the key part of this is that you're not bringing the server, all the server capabilities with you. That's been packaged and bolted on. Okay. And again, you get some tests that sort of come alongside with that as well. So this package will run and test against that API. So there's that sort of full software development lifecycle that comes along with it as well. Okay, sort of. So what I've done here is, this is one that I sort of built. I built earlier. So it also has. You can also run and sort of debug within this environment as well. So it's going to go off and do sort of initial build, and we'll just wait for that to sort of kick off and complete.
So is this
Anton? Does this does Appsody actually take care of the kind of Docker file and all of that sort of thing as well?
Yeah, that's actually a really good point. So, and this is the sort of key point about Appsody. As you can see within the Appsody project, there's no Docker file. Developers don't have to think about Docker. They don't have to think about Kubernetes. All they think about is, I'm building a library. In the background, what you get is the Docker file, and all the packaging of the project is taken care of within this stack definition. So within there is a Docker file that specifies how it's built. There's also it's gone here. So this is where you can specify, when I do a run for this type of project, what exactly do I want to happen. So if I do a run, I just want to do a cargo run, and I want to point to a specific toml within the environment. If I want to do a debug build, I want to attach. I want to run the application within the Docker container. I want to attach the GCC, the GDB server to that Docker container, so I can actually step through some code. And you can set that up within this environment as well. So it's using all the sort of normal technology. Again, this is all open source stuff. There's nothing proprietary in this at all. But the idea is to have that separation between sort of the definition of a project and actually building a project.
Yeah, that's pretty cool. Thanks.
Yeah. So a lot of it came out of, the main driver for this project was, I don't know if you use Cloud Foundry or Pivotal's Cloud Foundry. So that workflow, they've got a very similar workflow in that, but the actual building of these definitions is very, very complex. Whereas this is more Docker-based and more natural. It sort of leans more towards the Docker technology. It uses the Docker technology more than the Pivotal Cloud Foundry work did previously. So it feels like the way that you compose sort of layers on layers of, you get your server image, and then you have a running instance of that server image. You get your local code base, copy that code base into your image, and then build in order to get an environment. It's quite good. So
is that Docker stack file a special kind of Docker file, or just plain old Docker file?
No, it's just a plain old Docker file, and it's just called Docker stack because just to identify that this is the stack definition. So you can have multiple Docker files. I think I've got 2 in here, just the way that I want to compose my application. But it's not a particular spin on it. It's just called Docker stack because that's the default. There's a tutorial on how you build these things, and it's just the default name for it. So I just kept it. And again, there's sort of alongside that, there's alongside with the definition of these, the full sort of test framework for when you're building these things out. So you can validate, you can run Appsody validate, and it will validate all of this sort of, all of the build for you, make sure that it works with your sample project, et cetera, et cetera. So you've got quite a hardened thing at the end of it. How's my build doing?
Rust's Achilles heel.
Oh, absolutely. I was worried about this. I was actually going to pre-run it.
That's okay. It spends more time running in production than it does building, so it's okay. That's my take on it.
Yeah,
Very much so.
As they say, Rust builds fast applications slowly.
Yeah. There's actually the reason why I wanted to show you this run as well. So it's actually quite a nice feature that sort of helps with this problem. Yeah. So again, if I jump into, it's a bit more on stacks while that's building away. So again, so we're sort of looking at this, and from this side, looking at the user app and this idea of a controller, or this application that we put the user app into, and it's all bundled together at sort of runtime. And it also, in certain scenarios, it can also define a deployment operator for your Kubernetes environment. I don't use it for this particular instance, but it can support, especially in sort of when you want to containerize more stateful type of applications. It has got quite sort of extensive capabilities within the product, but within the framework. But for what we're doing here, you don't really need, for stateless services, you don't really need operators. But like I say, I think it's just interesting, and the reason why I wanted to bring it along today was back to what's in the community to help sort of businesses adopt Rust within their organizations. And I think the fact that sort of organizations like Red Hat, like IBM, are sort of investing in this type of technology to enable organizations to, if they want to use Rust, that's fine. If whatever you want to use, but just to provide the tooling to enable application team to manage that within container environments, I think it's pretty good, and more people should know about it, really. So where we got to? Okay, cool. Right, so we've got this up here. And so we have this on local. Where's it gone here? 8,000. Yeah, okay, so we've got this hello Rust Dublin sort of running here. But what I like about what you can do within this environment is, and you can see sort of I'm getting sort of logging information coming through from the Tide middleware here. But let's say goodbye. And when I save that, Appsody will automatically stop, notice the file's been changed, and do a recompilation for me, like sort of in flight. So when I go back to this now, it says goodbye Rust. So once you have it up and running, your sort of developer experience it's what you would expect from sort of a standard programming language. So don't be restarting your service all the time, but even when you say you had a compilation error, it would still keep the normal sort of developer experience that you get, where you make break, change it back, get it running again. You wouldn't have to do a sort of full end-to-end compilation. So there are some quite smart tricks going on in the background to make sure it's while you are building and developing in containers, it feels a very native experience as well. Okay. So once you've built that away, you can do an Appsody deploy, which if we have a look at this one now. So I'm just going to stop this container. So once it's what I want it to be, I can basically do a build, and it will automatically build that using the sort of standard -- release for your Rust service build. So everything's sort of done ready for production, and it will push it automatically to whatever Docker registry that you have, and it will also configure it ready to be used within sort of a Knative environment. Okay, so when you run with this flag / Knative, you get a generated for you, you get a deploy YAML that's created for you automatically, and you can use that then to push it to a Knative environment. All right, or if you didn't want to use Knative and you just wanted to use a container environment, you could use it without the Knative flag and just push it to your. It will still generate the deployment file, and you can still push it to your Kubernetes cluster as well. Okay, and I see a lot of developers struggle with deployment definitions, etc., when they're using Kubernetes. It really shouldn't be done by developers. It should be generated by the tool and pushed. And if there's any sort of additional configuration that needs to be done, that should be done as part of the CI/CD tooling. Definitely shouldn't be done as part of the software development lifecycle anyway. So, given the fact that it took us 5 minutes to build the debug version, I'm not going to build the release version, but I do have one that I've sort of deployed already. So I have I've got an OpenShift cluster up on my environment here, and I've configured it for serverless. So there's 2 operators that you can install into your OpenShift environment that makes it work in a serverless fashion. It literally 10 minutes to install it into the cluster, and it gives you this serverless tab with the services that have been defined, with services, the revisions of those services that I mentioned previously, and the routes. So how is this being moved, or how is this being made accessible to the outside world? Okay, and when I do the command, which one are we in here now? So when from Appsody, I do this Appsody deploy. No build, because I've already done my build, and I give it the Knative flag. Because I'm already logged into my OpenShift cluster, it will automatically push it to OpenShift, generate a URL for me, and make that URL available on the internet there. And comes back, hello, Rust Dublin. And it kind of is that simple. And that's really how you want your sort of development experience in a container environment to be. You want to really know as little about the fact you're using containers and you're using this Kubernetes as much as possible, really. And Rust, now that Rust has an async, has landed async, and we're seeing growth in the HTTP service world, I think marrying the 2 together is it's quite a good idea, and there's a lot of benefits in it. Okay. So that was the demo to finish off with. I'm sort of conscious it went on for almost an hour there. So thanks for sticking with me, everybody. I hope it wasn't that bad. I know there's a sort of a lot of concepts that if you're not using containers, I don't know how relevant they are with you, but hopefully somebody found it a bit useful. And I'll post these slides up. This what we stepped through there. Actually, I'll pull that up here. So the bits of tutorials that we went through there. Where are we on here? So this building a Rust application in a Knative environment, I've written that up on Appsody.com. So the full sort of end-to-end tutorial. You can run a little Minikube if you don't want to pay for a Kubernetes cluster somewhere, or we have a Knative service now on IBM Cloud that you can use free of charge. You can go and use that. There's the whole sort of step-by-step, basically everything that I ran through there in the demo, but do it, you can do it for yourself there. So there's links to that. And what else do I have here? Yeah, I've got tutorials in how to create the stack as well, and Shift. I've got some links to the documentation there, and then there's links to the specific references that I use throughout the slides. They're actually on the slides. Okay. So, and with that,
thank you, Anton. Yeah, are there any questions, comments?
Anton, how big are the Docker files you generate? Because I mean, one of the things that's quite interesting about Rust is you land up with a single binary that's probably 5 to 10 megs or something like that. When you build a container for Node, or you build a container for C# or Java or something, you typically land up with a 100 megs of runtime in there as well.
Yep. So they are bare minimum. I'm using, I think, actually for the deployments, I'm using just Buster. So I build using Buster, and then I have a Buster Slim actually that I deploy. Once I've done the build, I copy that out of the build container and copy it over to a runtime container, which has got nothing in it, just the binary. So it'll be as slim as you can possibly have it. Yeah, obviously a lot slimmer than your sort of runtime, your Javas or your Nodes. Absolutely. I can get numbers if you wish, but it's going to be around. I'd say it's going to be around the 200 meg.
Okay. So you could put it on Alpine or something like that and get it down a bit if you wanted to, but I guess it's not such a big deal. I did see some tutorials about how to do that. Kind of involves compiling to a slightly different Rust target that doesn't depend on libc and things like that, but yeah.
Don't do that. My advice.
Good advice. Okay.
Well, don't do that. If you, for me, the disk space isn't as much as a constraint as compute and memory. So it's not necessarily a lot of. I've had a lot of challenges using Alpine, especially with Java and some of the native. When Java has needed some native components, and similar with Node as well. When Node's needed native components, and you're trying to do a build on Alpine, it craps out, and so everybody some DevOps wizards put this together, and the developers are scratching their head as to why doesn't the library that they've included work anymore?
Right.
It's a trade-off,
Yeah.
But yeah, you can use Alpine if you wish.